now we have covered up to 3 parts. Okay, so all the parts should be covered and should be revised. Without that we cannot go forward, and without that we cannot solve the miscellaneous exercise or understand the problem. So kindly practice, practice and practice. Welcome back to our channel AnganaStudyCenter. Today we will discuss about the rest of the function. In previous class we have done up to polynomial function. Today we will know some new real function and their graphs and some exercise and miscellaneous exercise. So let's start our class. Just look at this question. This is the example of a polynomial function. Define the function f such that r2 r by y is equal to fx is equal to x square. X belong to r. Complete the table below by using the definition. What is the domain and range? So we first do the table. If we put here, look at this equation. Y is equal to x square. If we put x equal to first value minus 2, then we get minus 2 square equal to 4. So here will be 4. Then if we put x equal to minus 1, here minus 1 square, that means 1. Okay. Then put 0, 0 square, 0, 0. If we put 1, 1 square equal to 1. So this is 1. And if we put 2 square equal to 4. So 4. So here, just look. Here domain will be the x and range will be the y. So domain is x such that x belong to r. Okay. And range is the y, that means x square. Such that x belong to r. Okay. So if there is a question, please draw the graph of this equation. So how we get this graph? This is the axis, x dash, y dash. Okay. Now this is the origin. So 1, 2, 3, 4 up to 4. 1, 2, 3, 4. Okay, up to 4. This is 2, this is 3, this is 1. 1, 2, 3, 4. Minus 4, minus 3, minus 2, minus 1. Up to 1, 2, 3, 4. Minus 4, minus 3, minus 2, minus 1. Okay. So for the first point, minus 2, 4. Then this and this point will be here. And up, then the next point, minus 1, 1. Minus 1, 1. That is 0, 0. That means this point. After that, 1, 1. 1, 1 means this is. After that, 2, 4. If we join this point, we get a U shape. Okay. This is the graph of this polynomial function. Y is equal to x square. Okay. This should be remembered. Look at this question. Draw the graph of the function f such that r2 are defined by fx equal to x cube. This is also a polynomial function. So x belong to r. So now first we put the value of x from r. Here fx is equal to x cube. That is y is equal to x cube. Now putting the value of x from r. Now we first put if x equal to minus 2, then y equal to minus 2 cube, that means minus 8. Okay. If x equal to minus 1, then y equal to minus 1. Okay. If x equal to 0, y equal to 0, y equal to 0. Then x equal to 1, y equal to 1. If x equal to 2, y equal to 8. Okay. So now by the graph, if we draw, this is 0, x dash, y dash. Now 1, 2. Okay. 1, 2. Minus 1, minus 2. Okay. This is 1, this is 2. Minus 1, minus 2. Okay. If put this first value, first point coordinates, we get x equal to minus 2, y equal to minus 8. So here minus 8 up to minus 8. 3, 4, 5, 6, 7, 8. This is minus 8. Assume 3, 4, 5, 6, 7, 8. This is 8. Right? Assume. Okay. So minus 2 means from this to this point. Okay, and then -1 -1, that means -1 -1, that means this is. Okay, then 0 0 mean this. Okay, then 1 1, that means this point. Okay, then 2 8, that means that is sorry, -8 should be here. Okay, so if we join these points, we get this and this. This type of graph will be appear. Okay, then this is the graph of y is equal to x cube. This is also a polynomial function. This should be remembered. Now we'll learn about the rational function. Rational function is the function, a type of fx by gx. Okay, fx by gx, where fx and gx are the polynomial function. Okay, at the polynomial function, and x is defined in domain and gx not equal to 0. If this condition is satisfied, then fx by gx is called a rational function. Okay, now looking for some example. Let's look at the question. Define the real value function f such that f minus 0, that means in R 0 is not present. Okay, to R defined by fx equal to 1 by x, x belong to R minus 0. Fill up the table below and what is the domain and range. So if we put x equal to -2, then y equal to the value of y minus half, that means minus 0.5. So this is minus 0.5. Okay, if we put x equal to -1, then y equal to -1. Okay, if we put x equal to 1, y equal to 1 by 1, that means 1, that is 1. If x equal to 2, we get y equal to 1 by 2, that means 0.5, that means 0.5. Okay, so here just look, domain, here x belong to R minus 0, that means all the real number except 0, that means domain will be set of all real numbers except 0. Okay, and range will be the all real number, set of all real number. If we draw the graph x, x dash, y, y dash, this is the origin. This for 0.5, 1, 1.5, this is 2, this is 0.5, this is 1, this is 1.5, this is 2. Okay, and this is minus 0.5, this is 1, this is minus 1, minus 1.5, minus 2, and this is minus 0.5, minus 1, minus 1.5, and minus 2. Okay, now putting the value of x, y, here x minus 2 and y also minus 0.5. So minus 2 and minus 0.5 will be this point, and then minus 1, that means minus 1 and it will be minus 1. Okay, this is 2 points, and now 1 and 1, that means 1, 1, this point. Okay, and then 2, 0.5, 2, 0.5. Okay, so just look, if we take some other point, so here the graph will be downward, from upper level to downward. So this is this type, and this also from upper to downward. So this type of graph will be established for the equation y is equal to 1 by x. This should be remembered. Okay, learn about the modulus function. Okay, the word modulus you have heard before. Okay, within mod the value of any negative or positive, the value will be as output always absolute value. So all time positive. Okay. The function f such that r to r defined by fx is equal to mod x. X belong to R is called modulus function. Okay. Here one thing should be noted: for all value of x, the value, the fx will be equal to x. That is absolute value. And for all values, for negative values of x, the fx will be equal to negative of x. That means fx is equal to mod x. Then we get plus x when x greater than 0, minus x when x less than 0. Okay, this is greater equal to 0. Okay, here just look at this equation. Y is equal to mod x. Okay, now x belong to R, so just putting x equal to minus 2, we get y equal to, so y equal to within mod minus 2, that means 2, and x equal to minus 1, so y equal to 1, x equal to 0, y equal to 0, x equal to 1, y equal to 1, x equal to 2, we get y equal to 2. If we draw a graph x dash, y dash, okay, then this is the origin. If we put the first value minus 2, 2, 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4, okay, then minus 2, that means this is, and this will be 2, okay, this point, then minus 1 1, so minus 1, this is 1, so this point, now 0 0, that means this, and now 1 1, that means this point, okay, then 2 2 2, that means this point, okay. So if we join these points, we get this type of graph, okay. This is the graph of y is equal to mod x. This should be remembered all time. Here the domain will be of this function, domain will be the set of all real number, okay. And range will be what we found, non-negative real number. Okay, clear? We are going to learn about the Signum function. What is the Signum function? A function f such that R to R is defined by fx equal to 1 if x greater than 0, 0 if x equal to 0, minus 1 if x less than 0. Okay, then the function is called Signum function. Okay, x belong to what? That means the value of x less than 0 and above 0. So the domain will be set of all real number, and range of f equal to this particular value, that means 1 0 and minus 1 we can get. Okay, so within curly bracket 1 0 and minus 1 will be the range. If we draw the graph, what will be the graph? X dash, y dash. Okay, so this is the origin. If we put y equal to 1 when x greater than 0, okay, y equal to 0 when x equal to 0. So first do this, x equal to 0. That means here and y equal to 0. And from here, if 1, 2, here 1, here 2, here minus 1, minus 2, and here minus 1, minus 2. Okay. So now y equal to 1. That means here, and the value of x greater than 0. That means from here the arrow will be up to the towards the positive direction. Okay. If y equal to minus 1, when x less than 0, that means x, the value of x may be vary, but y is minus 1. So here the direction towards the negative value, y is equal to minus 1, and the direction towards the negative value. So this is the graph of Signum function fx equal to 1, 0 and minus 1. When x greater than 0, x equal to 0. When x less than 0. Okay, this should be remembered. Now going to learn about the greatest integer function. This is most important. A function f psi that r to r, okay, is defined by fx equal to within third bracket x. That means the greatest integer value of x. Okay, x belong to r. This is the greatest integer value. Okay, that means less than or equal to x. Okay, suppose if we have 1.99, then the greatest integer value will be 1. Okay, if we have minus 3.5, then the greatest integer value will be minus 4. Okay, so the value will be downward. Okay, if we take the greatest integer value here, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5 and 6. Here minus 1, minus 2, minus 3, minus 4. Here we have a value just 5.6. Okay, 5.6. So here, so the greatest integer value will be 5. So here the closed circle and here the open circle. Okay, if we have minus 3.6, then the greatest integer value minus 4. That means from 3 to minus 4, from minus 3 to minus 4. That means here all the integers are towards the lowest value. Okay, now by graph we can see this. Here x dash, here y dash, here y. 1, 2, 3, 4, here minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. Here minus 1, minus 2, minus 3 and minus 4. Just suppose if we have within bracket x equal to minus 1, where minus 1 lesser equal to x less than 0. That means 0 is the highest value and x is lesser equal. Lesser equal means from here closed circle start and here will be end with open circle. Okay, then if x equal to 0 for 0 lesser equal to x less than minus 1, sorry, less than 1. Okay, that means from here open circle and here is the closed circle. If 2 to 1, there is open, here is closed. Okay, if 3 to 2, there is open in 3 and here closed. Similarly minus 1 to minus 2, that means here is closed. Minus 2 to minus 3, that means here open, here close. Okay. Similarly, 4 here open, here close. Okay. This is the graph of within bracket x. That means constant integer function. Okay. Fx equal to within bracket x. Okay. Then the domain will be R. That means set of all real number, and the range, what will find? All the integer. That means set of all integer. Okay. We are going to know about the addition of two real functions. In number system, we are doing the sum between two numbers, subtraction between two numbers. Similarly, like that, in function there are addition, subtraction, quotient, etc. Okay, multiplication. Okay, so let f(x), let f is a function such that x tends to r, and g also a function x tends to r, where x is a subset of r. Then the addition of two functions is defined by f plus g x equal to fx plus gx. Okay, when for all x belong to capital X. Okay, that means two functions are exist here, and x is a subset of r. So f plus g x equal to fx plus g. Simple matter. Okay, then subtraction. Similarly, if these two functions are exist and x subset of r, then the subtraction of two functions is defined by f plus g such that x tends to r, that is f minus g tends to r, f minus gx equal to fx minus gx for all x belong to capital X. Okay, then multiplication. The multiplication will be defined by f dot g such that x tends to r, that is f dot g x equal to fx dot gx for all x belong to capital X. Okay, this multiplication function is also called pointwise multiplication. Okay, now we have only one left, that is quotient of two functions. Quotient of function. What is quotient of two functions? Let fx gx are two functions, x subset of r. Then the quotient of two functions is defined by f by g such that capital X tends to r. Okay, that is fx by gx. That is f by g x equal to fx by gx, provided gx not equal to 0 and for all x belong to capital X. Okay, now look an example. Just look at this question. Here fx equal to root x and gx equal to x are two real function, non-negative. Find the f plus gx, f minus gx, f gx and f by gx. just look at this. F plus gx equal to, we know, fx plus gx. So fx equal to root x and gx equal to x. Okay, if we common root x, we get 1 plus root x. Now second, f minus gx equal to fx minus gx, that means root x minus x. Fg dot x equal to fx dot gx, that means root x dot x, that means x root x, that means x into 1 plus half, that means x to the power 3 2. And f by gx equal to fx by gx, that means root x by x, that means x to the power half minus 1, that means x to the power minus half. Okay, that means 1 by root x, provided x not equal to 0. Okay, this type of question may be correct. Now we are going to do the exercise number 2.3 of your NCERT textbook. Just look at the question. Here it says, who is the following relation of function? Give the reason. If it is function, then determine the domain and range. Now, in the first, we have seen here all the first elements 2, 5, 8, 11, 14 and 17. Okay. So, here all the first elements have a unique image. So, it is obviously a function. Okay. Then what will be the domain? Domain will be 2, 5, 8, 11, 14, 2, 5, 8, 11, 14 and 17. And range will be the second set of all the second element in ordered pair of relation. That means here is only 1. Okay. Then question number 2. Here just look. The first elements are 2, 4, 6, 8, 10, 12, 14. So here is no repetition of the first element. So, and in the second element there is only one and only one image. So this is also function. Okay. And the domain will be the set of all the first element, that is 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14. And range will be the second set of all the second element in ordered pair in the relation. That means 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So now doing the third question, 1, 1, 2. Now just look. Here the first element 1 also repeated in second pair. So this is not a function. There is only one image. Here the image of 1 is 3 and also the image of 1 is 5. So here is 2 images. So not this is not function. As the first element 1 is repeated. So it has more than one image. Okay. Just look at this question. Find the domain and range of the following real function. So here we will find the domain and range of these two functions. For the first, fx equal to minus mod x. Here obviously x belong to R as this is the real function. So now put x equal to minus 1. Then fx, that means y. Y equal to minus, within mod minus 1 will be the absolute value, that means 1. If x equal to minus 2, then y equal to minus 2. Okay. If x equal to 0, y equal to 0. So every time we get the minus value and for 0 we get 0. So here the domain will be R, that means set of all real number, and the range will be up to infinity. Up to infinity. So within first bracket infinity, comma, that is the n value of x is 0, y is 0. So within third bracket this will be the range. Okay. Now question number 2. Fx equal to root of 9 minus x square. So we put x equal to just minus 1. Y equal to we get 9 minus 1, that means root 8. Okay. X equal to minus 2. Y equal to root 5. X equal to minus 3. Y equal to 9 minus 9, that means 0. Okay. For minus 3, we get 0. If x equal to 3, y equal to also 0. X equal to 2, we get y equal to root 5. X equal to 1, we get y equal to root 8. If x equal to 0, y equal to 3. Okay. So the domain will be x higher minus 3 lesser equal to x less equal to 3. That means range will be x either 0 lesser equal to x lesser equal to 3. Okay. Let fx equal to 2x minus 5. Write down the value of f0, f7 and f minus 3. For this fx equal to 2x minus 5. Now put x equal to 0. Then f0 equal to 2.0 minus 5. That means minus 5. Okay. For this put x equal to 7. So f7 will be 2.7 minus 5. 14 minus 5, that means 9. For this put x equal to minus 3. Then f minus 3 equal to 2 dot minus 3 minus 5. That means minus 6 minus 5. That means minus 11. Okay. Now look at this question. Here t is equal to 9c by 5 plus 32. Find t0, t28, t minus 10 and the value of c when tc equal to 2 and 2. First three questions are same as this question, that is number 3. So I am going to do this question. Number 4. Here find the value of c when tc equal to 2 and 2. So we have tc equal to 9c by 5 plus 32. Then there is given tc equal to 2 and 2. Now putting the value of 2c implies that 2 and 2 equal to 9c by 5 plus 32, or 9c by 5 equal to 2 and 2 minus 32, that means 0, 8, 1, 180. So by divide that we get 2 0, that means or c equal to 100. Okay, this will be the answer. Now look at this question. Find the range of the following function. Here three functions has been given. So we are going to do the question number 1. Fx equal to 2 minus 3x, where x belong to R and x greater than 0. If x equal to 0, then y mean y is equal to fx, then mean that will be 2. So here we will find the range. So the value of y. So the value of y should be below 2. Okay. Then when x equal to 1, okay, then y equal to minus 1. When x equal to 2, y equal to 6 mean minus 4. X equal to 3, y equal to minus 7. So we see the range will be the value of y up to 2. Upper limit is 2. So here the range will be 2 within first bracket, and here the value up to infinity. That means minus infinity, comma 0, yeah, comma 2. Okay, will be the range. The first question have been done. Second question. Fx equal to x square by 2. Here x is the real number. Okay, if we put x equal to minus 2, then y equal to 6, x equal to minus 1, y equal to 3, x equal to 0, y equal to 2, x equal to 1, y equal to 3, x equal to 2, y equal to 6, x equal to 3 or minus 3, then y equal to 11. So just look at the value of y. The lower value is the 2. So the range will be within third bracket 2 comma up to infinity. Okay, within end with the first bracket. Okay, now question number 3. Fx equal to x. Okay, now putting when x equal to 0, y equal to 0, x equal to minus 1, y equal to minus 1, x equal to minus 2, y equal to minus 2, x equal to 1, y equal to 1, x equal to 2, y equal to 2. So here we find from minus infinity up to plus infinity the value of y can be. So the range will be within first bracket minus infinity to infinity. Okay, that's all for today's class. In the next class we will revise all the chapter and we will do some miscellaneous example and solve all the miscellaneous exercise of your NCERT textbook. Please revise all the things we have covered. Till now we have covered up to 3 parts. Okay, so all the parts should be covered and should be revised. Without that we cannot go forward, and without that we cannot solve the miscellaneous exercise or understand the problem. So kindly practice and practice. So thanks for watching our video.